circuits. We're going to talk about current right now. Current is really simply defined as the rate of flow of charge. How quickly is charge moving through a wire or a circuit or whatever. The reason we're going to deal with this is we're going to start moving into what are circuits. And this idea of how do you light a light bulb? How does your house work? How does all this stuff get electricity moving through it? You're going to be running around your house this week and next week. I'm going to have you going outside. We got some stuff we got to do. So, really simply, current is defined as this idea of the rate at which charge flows with time. Now, annoyingly enough, the symbol for current is I. Why? I don't know. What do we measure current in? Amperes. Or just amps. So you would say I would have 2 amps flowing through a wire. All right. What is an amp? It's 1 coulomb per second. All right. Now, one of the annoying parts is current is defined as the flow of positive charges. Why is that annoying? Do positive actually move? No, but we treat them as if they do. So current is this flow of positive charges that lets us use this voltage we've been talking about. That lets us use this electric field we've been talking about because it deals with how the positives react to those things. All right. What I want you to look at, in your house, you either have circuit breakers or fuses. All right. I'm going to ask you later to go find yours, but don't touch them. The reason we have these things here, they're safety devices. What they do is they limit the flow. You'll find most circuit breakers are probably set to either 20 amps or 50 amps. That means that no more than that amount can flow. It's a safety issue. You got to have this idea of not too much current so it doesn't heat up and like burn your walls. That would be a bad idea. Fuses are very similar ideas, but instead of being resettable, you have to replace them. What a fuse does, it kind of looks like this. You're going to have this thing you screw into the wall, and current flows through it like that. If too much flows, this little section right here can melt, and that breaks the circuit. All right, circuit breakers, they're just switches, you can flip them back. So when you're dealing with current, you have this idea of voltage pushing the charge. So let's say you have a circuit with a simple battery in it, and then a light bulb. The battery makes a lot of voltage. The charge gains energy. The battery kind of forces it up the hill. It's kind of like a roller coaster. The light bulb uses up that voltage. It uses up that energy. What does it turn into? Light and heat mainly. Charges try to lose energy. They want to go down this hill, but the battery says no and forces them up and then lets them fall down when they go through the object. All right. Real simple. Let's say you have a fuse that has a maximum of 5 amps. Flows with that maximum for half a second. How much charge flows through it? Well, we can say I, the current, is how much charge over how much time. We have a current, we're looking for a charge, and we have a time. So our Q is 2.5 coulombs. That's a lot of charge. All right. Your outlets in your house have 120 volts. If you look on any electrical device, and I'm going to ask you to do this later, there's a measurement of how much current they allow through them. 1.2 amps is like a computer charger, whatever. It's the idea that we have how much charge in a certain amount of time, and we can talk about how much energy. We can talk about power. We'll get to that later. I just wanted to lay that out for you. There's an assignment coming up that I want you to look into. I want you to find your fuse box, and I want you to take a picture of it, and I want you to look at what's going on.